Dear students, hope you are great. Today we are going to continue Unit 2, the structure of matter, Chapter 3, properties of matter, Section 1. In the last session, we took the meaning of matter. We said that matter has a mass and volume, and we took the meaning of. So matter has mass and volume. We took the meaning of volume and how to measure the volume of liquid and solid, either regular solid object or irregular solid object. So we took how to measure meaning of the volume and how to measure volume of liquid and solid. Matter has another characteristic, which is mass. So another characteristic of all matter is mass. What's meant by mass? Mass is a measure of the amount of matter that makes up an object. So mass measures the amount of matter that make up an object. For example, monkey and peanut both are matter, are made of matter, but monkey are made up of more matter than peanut. So monkey have a greater mass than peanut. So the mass of an object does not change when the object location change. So when the object location change, the mass does not change. The mass does not change. But if the amount of the matter change, the mass of object change. So the mass of an object changes only when the amount of matter that makes up the object change. The difference between mass and weight. The terms mass and weight are often used as so they mean the same meaning, but they do not. So mass and weight do not the same thing. Weight is used to measure gravitational force of an object. So weight measure gravitational force of on an object. What's meant by gravitational force? Gravitational force keeps objects on Earth from floating into space. So gravitational force, the important gravitational force to keep object on Earth from floating into the space, to keep this girl to be on Earth from floating into the space. Gravitational force between an object and Earth depends partially on object mass. So gravitational force depends on object. The greater the mass of an object, the greater the gravitational force on an object. If you have two objects, mass of first one is greater than second one, so the gravitational force of the first one is greater than second one, and the greater the object weight. But an object weight can change depending on the object location. So weight depends on object location, but mass does not depend on object location. For example, an object would weight less on the moon. Object weight less on the moon than it does on the Earth. Why? girl number A, number B. Girl here on the earth is weight 560 Newton, but on the moon around 90. Why this girl weight less on the moon? Earth has a greater mass than moon, so moon less mass. So earth that has greater mass also have greater gravitational force, greater than moon, greater gravitational force, gravitational than moon. So this girl weight more on the earth than on the moon. An object would weight less on the moon than it does on earth because the moon has less mass and therefore less gravitational force than earth. This comparison between weight and mass. Weight, which is mean or measured gravitational force on an object, but mass measures the amount of matter that contained in an object. Weight change according to places, according to location. So the weight of this girl, so the weight of this girl on the moon weight more than on, so the weight of the girl on the earth weight more than on the moon. Mass remains the same at all places. Unit that used to measure the weight is Newton, but mass kilogram. Weight measured using spring balance or spring scale, but mass used a normal or an electric balance, lever balance, beam balance, or an electronic balance. Watch this video.
Let's accept it. Most of us think that mass and weight are pretty much the same thing. Are they? No, they're not. There's a very simple way to understand the difference. Mass is simply the amount of matter that's present in the object. Now consider two situations. One in which an object is on the earth, and second in which the same object is on the moon. Will the mass of the object be different in these cases? To answer this question, we ask ourselves another simple question. Will the amount of matter present in the object be different in these cases? Absolutely not. The matter in the object is not changing at all, which is why the mass will be the same in each of the cases. The mass of an object remains constant no matter where it is placed. The standard metric unit of mass is the kilogram. Another concept we'd learnt about an object's mass was that it is a measure of its inertia. Greater the mass of an object, greater will be its inertia. Inertia is nothing but the tendency of an object to resist change in its state of motion. So now we have an idea about what mass is. But what's weight then? How do we understand the weight of an object? Mass is nothing but the measure of how much matter an object has. Weight is a measure of how strongly gravity pulls on that matter. It's the measurement of the gravitational pull of an object. Let's understand this using a simple example. Say there are two places, place A and place B, and there's an object of mass m. In place A, the pull of gravity is x units, and in place B, the pull of gravity is 2x units. Clearly, the pull of gravity is stronger at place B. Now understand this well. the mass of the object will be m at both the places, but the weight of the object will be greater at place B because the pull of gravity is stronger. As the gravity is twice as bigger, the weight of the object will be twice as much at place B as compared to place A. So the weight of an object is a measurement of gravitational force acting on it. How can we understand weight using a formula? We know the Newton's second law of motion, which says that the force acting on an object is the product of its mass and acceleration.
That's it. Thanks for watching.